Hi all, welcome to the final video on the biosphere topic, and in today's video we're going to be looking at our third and final soil profile, that of Gley soils, or sometimes also called tundra Gley soils. Now, as we have before, we're going to spend our time looking at the example soil profile here, and we're just going to talk through the different characteristics and processes that we associate with this soil. Now, Gley soils we tend to find have quite a varied vegetation load on top. A lot of the time it can be deciduous woodland or it can be moorland and stuff like that as well. So it can be reasonably varied, particularly given that a lot of the places in Scotland where we find these soils are at the bottom of glens in the Highlands, which, depending on aspect and climatic conditions, can have quite a big impact on what type of vegetation is able to grow there. But we can operate for this that we're going to have a more deciduous style vegetative load. Now, other characteristics, as a rule, we're going to have precipitation exceeding evapotranspiration, but quite often with Gley soils we find that during the summer we've got higher rates of evapotranspiration, and the reason we bring that in and the reason that it's important to mention here is because it has an impact on the water table. Now, something that's just worth pointing out at this stage, because it's not really been hugely relevant up till now, where the water table sits with a tundra Gley soil has a big impact on that soil and on how it forms. Now, the water table is just the natural level that groundwater sits at in any area. Now, particularly with Gley soils, we're going to be talking about areas that are waterlogged, and that obviously means that the water table is above that particular section of soil, which is extremely important. And when we get to talk about the E horizon with Gley soils, we're looking at an area where we've got a fluctuating water table which has some kind of interesting side effects, and we'll discuss that more when we get there. But to start from the top working down, so we're going to have our leaf litter layer, the same as the other bits with our O horizon. We're going to have fermentation and humification layers, and it's going to create, largely speaking, a more humus in these areas. These areas tend to be colder, so it has a big impact on the volume and the amount of chemical reactions that we can have taking place, and that has an impact on the rate of decomposition and humification, so it tends to slow it down. Now, as I say, we do get some of the stuff, some of these minerals and materials being broken down in the horizon, which does tend to give it a kind of a dark brown colour. However, we do see a fair amount of leaching happening here, which is going to drive a lot of these nutrients out of this top A horizon. Now, as we move down, Gleys are the first soil profile we have that have got a very pronounced E, or a very pronounced alluviated horizon. So this is where we are seeing a lot of water, or a lot of water's movement, dragging minerals out of this horizon. Now, depending on what the water table is doing, that will vary where those minerals are going. If the water table is going up, it will bring some of the minerals up. If the water table is dropping, it will take some of the minerals down. Now, one of the big things that we see here is that because we have got occasional aeration of the soil, when the soil is flooded, when the soil is waterlogged, there is very little oxygen in the soil at that point. However, when the water table drops off again, oxygen can get into the soil, and that can allow different chemical reactions to take place. Particularly, we see iron oxidizing into its ferrous forms, or its ferric forms, Now, that has an impact on the soil because it turns out a very pronounced yellowy brown colour, which is one of the big things that we can start to tell that this makes our Gley soil. What we'll also start to get here is we'll move down to the proper boundary with our B horizon, because again, in this soil, unlike brown earth, this soil does have nice pronounced layers because we've got nice pronounced colour changes that tell us as we're moving into different layers. As we move into the B horizon, it's going to get basically more or less constantly waterlogged, and that results in anaerobic conditions. Now, that means that decomposing organic matter accumulates in this area, and it doesn't necessarily decompose particularly quickly, and we start to see reduction occurring as opposed to oxidization. So this is where the iron is going to move from their ferric to their ferrous state. Now, why is that particularly important? Again, as we have this ferrous iron created, it then gets removed from the soil because it's soluble, and that results in the materials left behind being quite blue or grey, and you sometimes get some greens coming in at this point as well. So we're talking about a horizon, I say it's very, very moist. We tend to have lots of clays. It's blue, grey, green in colour because we've got no oxygen. So the iron turns from its ferric to its ferrous state, and when it's in its ferrous state, it's soluble, so it can dissolve into the water and then be removed, leaving that kind of bluey, greeny, grey colour behind. We then go, down into our sea horizon, which you might have a little bit of fairly permeable parent material, but the big point here is that you're going to have something right at the bottom which is impermeable. And again, that's important in this context, because if we don't have that impermeable base layer, we don't have the ability for this to become as waterlogged as it needs to be in order for us to get those different areas with our B horizon having a lot more reduction going on, and our E horizon, potentially having a lot more oxidization going on. So we move through the layers in our Gley, and we're talking about, a dark brown grey A horizon, moving into our yellowy brown stained E horizon, which is driven by the oxidization of iron into its ferric form. We then move last into our B horizon, which is going to be bluey, greeny, grey, because again, just one more time to repeat this point because it is important, as the iron moves from its ferric to its ferrous state, and then in that ferrous state it is soluble and it more readily moves out of the area in solution, resulting in the soil that's left behind taking on this bluey, green, grey colouring. Now that marks the end of Biosphere, guys. It also marks the end of the topics in Unit 1. So until next time, I will see you guys later. Bye.